consolidation video for Unit D, Lesson 7, Investigating Inequalities. Alright, so in this lesson, we learned what an inequality was, and we learned, how to represent numbers on a number line, and how to represent a number line with an inequality. Let's first establish what each of these symbols means. This symbol here is the less than symbol. We call this a less than symbol because we're reading left to right, right? If I were to say, 5 is less than 7, we read left to right. So 5 less than 7. Yes, that also means 7 greater than 5, but that would be reading right to left, which we don't typically do in English or in math, at least for English math or math in North America, right? So 5 is less than 7. This one means this one has the bar, so it also is less than, right? Because we can see that the less than sign is there. But what does that bar mean? That means that it can also be equal to. So it's less than, but it's also including that border. This one is the greater than, and then that would make this one the greater than or equal to, greater than or equal to. Okay, now let's work into solving some problems using these signs. List 3 numbers that satisfy the inequality x is less than 2. So what it boils down to is we need 3 numbers that are less than 2. And hopefully you know some of these, right? 1 is less than 2. 0 is less than 2. And negative 17 is less than 2. What number would not work here? 2 would not work. 3 would not work. And anything more than that, right? Anything 2 or greater is not going to work here. But 1 is possible, 0 is possible, and anything less than that is also possible. 1.9 is also possible here. Okay. Represent this inequality on a number line. We want the numbers that are greater than or equal to negative 4. When we're talking about number lines, sometimes it's important to think about what numbers are included in this. So before I even draw the number line, let's think about what numbers are greater than or equal to negative 4. So what's in, what's out? Well, the numbers negative 3, negative 2, 1, 7, those are all in, right? Those are greater than or equal to negative 4. Negative 4 is also greater than or equal to negative 4, right? Because it is the equal to part. And what's out? Well, negative 5 is out, negative 7 is out, negative 9 is out. So this kind of helps to kind of visualize what's going on. Negative 4 is going to be our border point. I'll do this in blue here. Because negative 4 is included in the relation. And we want all the numbers greater than or equal to that. So we are going to draw a line pointing right to say that 1 is included, 7 is included, negative 2 is included, all the numbers greater than negative 4 are included, and then this filled in dot means that negative 4 is included as well. Notice how numbers like negative 5, negative 7, negative 9 are not included. List 3 numbers that satisfy both these inequalities. We want numbers that are greater than or equal to negative 1 and less than 6. Well, numbers that are greater than, you can also kind of think of this as a Venn diagram even, right? If this is greater than or equal to negative 1, this is less than 6, right? There's numbers that are included in both, right? What are some examples of those numbers? Well, 0 is greater than negative 1 and less than 6, and maybe it just helps if we go up from there, right? 1 is included in that because it's greater than negative 1, less than 6. So is 2, so is 3, so is 4, so is 5. Note that negative 1 is also included because it's greater than or equal to negative 1. Okay, next up here, there's 3 numbers that satisfy this inequality. 3x plus 4 is less than or equal to negative 2. So this one's a bit tricky because it's harder to visualize, right? We could do trial and error, right? We could just plug in numbers and see what works. But we want ideally a little bit more efficient of a method. The one thing I will say is that we can treat inequality signs just like equal signs in most cases. Let's move this move the 4 over where it becomes a negative. So now let's say 3x is equal to negative 2 minus 4. Does that make it easier? Well, it should, right? Because now we know 3x is less than or equal to negative 6. That's a little bit easier to visualize because 3 times a number must be less than or equal to negative 6. Can we do it even more? Well, let's divide by 3. Now x is less than or equal to negative 2. This makes sense because if we were to multiply a number by 3 and it having to be less than negative 6, that means our number should be less than or equal to negative 2. Okay. Now we can just do this inequality. What satisfies this? Well, negative 3 does, negative 4 does, negative 5 does. This would be a little bit trickier to do in your head from the initial equation. All right, and then represent this equality. Negative 2 is less than or equal to x is less than 6. So we can do the whole in and out thing, but let me show you what it would look like if we didn't. We know negative 2 is in this inequality, and it's included through equality. So we can actually draw a filled in dot there, negative 2. We also know the other border of this equality is 6. But there is no bar under there. So we're going right up to 6, just not including 6. And when we're drawing these number lines, we represent this with a hole, meaning that it goes right up to 6, just doesn't include 6. And then it includes everything in between that. Right? So that is what that number line looks like. If you were to do the in and out thing, kind of like we did last time, right? Every number from negative 1 to 5 would be in there, including negative 2, right? Because negative 2 is included through equality, but every number before that and every number 6 and on is out, okay? So again, when I say represent this inequality, we're looking for the number line, but if the in and out thing helps you, then for sure do that, okay? So that's a lot about inequalities, and that has been your consolidation video for lesson 7.